In the last video, we looked at detectors and what specific charge was. In this video, we're going to have a little look at the particle zoo. If you remember before, we were making a list below of all the particles that the universe was made out of. We wanted to keep that number below 92 because that's what the periodic table had. We all found that far too complicated. These are all the particles that you could be asked about in A-level physics. And there's a lot more than this, and I'm not going to list all those in the table below. There are hundreds, if not thousands, of particles in the particle zoo. The nickname the particle zoo came about because all of a sudden, because we had the technology, we were able to detect more and more and more very different, very unique particles. And we gave them names according to their properties. But trying to find the relationship between all these particles was a bit like trying to find the relationship between animals in the zoo, trying to see if there's some sort of link between them. By examining the properties of these particles, we tried to determine if there were any connections, any way of simplifying this picture, because the particle zoo had more particles in it than the elements on the periodic table, by a long way. You'll see some familiar names on this table. We can start with those that you meet at GCSE level: protons, neutrons, electrons, and photons. But there are other familiar faces here. For example, the pion, pi0, which you remember 𝗟𝗶H predicted was the reason for the strong nuclear force. The kaon, which we discovered by accident when we were looking for pions, and the muons, which, if you remember, were very similar to electrons, but 200 times the mass. There's also neutrinos. That's the Greek letter nu. But there are other particles on this table. Particles like sigma particles, omega particles, xi particles, eta particles, lambda particles, delta particles, which you may never have heard of before. So we had to find some way of sorting this zoo. There are a few rules we can put in place. The first is that if a particle feels a strong nuclear force, let's call it a hadron, sometimes pronounced hadron. So hadrons are particles that feel the strong nuclear force. Done. We've got a classification now. We can start putting them, particles that feel a strong nuclear force, into that box. They're now called hadrons, or hadrons. Then we can say particles that don't feel the strong nuclear force. We need to put them in a box. Let's call those leptons. That's a family of particles that don't feel the strong nuclear force. That's what a lepton is. Now, all of these particles can feel the weak nuclear force, so we can't use that as a way of sorting particles into the two boxes. But within hadrons, there were two different types of particles. There were some who would eventually decay into protons, or they already were protons, and there were some that wouldn't. So those that would eventually decay into protons got called baryons, and those that wouldn't got called mesons. So breaking down the language here, maybe it will help. Bary means large, meso means medium, and lept means small. That's where the word leprechaun comes from. So you may have heard sort of mezzo, forte, and things like that, maybe if you're a musician, meso, medium. So these do have some sort of passing relationship to the mass of the particles, but it's not perfect. Instead, remember them in this way. Baryons decay into protons, mesons don't decay into protons, but they do still feel the strong nuclear force because they are still hadrons. Attempts to put the hadrons into some sort of periodic table were confusing. So here are some examples that I've pulled off Wikipedia, where baryons and nucleons sitting on the side here. It's not as elegant as the periodic table at all. And this is only 119 of these hadrons. So to be able to sort the particles further, we're going to have to explore some more particle properties. And I will do that in the next video.